Here we're asked to solve a compound inequality. We have two inequalities joined with the word or. We'll solve both of these individually and then consider the union of the two sets. For the first inequality, I notice we have a -1. So I'm going to choose to add 1 to both sides. That'll leave us with 4x is less than -4. Next, if we divide both sides by the coefficient here, 4, we'll have 1x is less than -1. In other words, any real number less than -1 will solve this inequality. Now let's solve the second one. Again, we have -1, so I'm going to choose to add 1 to both sides. In this case, we're left with 4x is greater than 6. Dividing both sides by 4, well, that leaves us with x is greater than 6/4, which reduces to 3/2. 3/2 is the same thing as 1.5. So any real number greater than 3/2 will solve this inequality. Let's graph both of those solution sets on a single number line. Here we have any number less than -1. Since this is a strict inequality, I'm going to use an open dot and shade all the real numbers less than. For this inequality, any number greater than 1.5. Let me label this 3/2 and use an open dot as well. This time we're going to shade every number greater than that. So here's all the solutions, all the real numbers that'll solve this inequality or that inequality. We can express this same set in interval notation as follows. For this tail we have -infinity to -1, parentheses, union 3/2 to infinity. So this is the interval notation equivalent for all the real numbers here that solve the original compound inequality.